Welcome students to the series of lecture on LangGraph. And in this series of lecture on LangGraph, this is going to be a very interesting conversation because today we will initiate the conversation on memory, a very critical concept, a very important concept. If you're trying to build any production level system, whether it is an agentic system, a chatbot, or any application where user experience is important, where the conversation understanding is important. So whenever there is user experience that is needed in any system, any chatbot, any agentic system, or conversational continuity matters, memory is important. Because without memory, there is no continuity. There is no continuity. Without memory, there is no continuity. And without continuity, there is no memory, and you won't feel intelligence. Even the intelligence is there, the LLMs are there. And now understand this very, very clearly because this is very subtle and very important, and we cannot cover everything in just one single lecture. So this memory in itself is going to be series of lecture because memory has very subtle complexity. So for example, one very important difference is there between memory and persistence. Yes, without persistence, you cannot implement memory in LangGraph. That is true. But memory itself is a different concept, and persistence is a different concept. Persistence is a physical concept. Memory is an abstract concept. If I say define memory for a human being, how will you define memory? Okay, brain is a physical matter, right? But memory, where it exists, so it is a non-physical concept. You can only feel memory. And therefore, the conversation of the memory is more to be felt. And therefore, this is going to be a series of lecture. And because of these kind of subtle discussion, we need to understand these concepts deeply, and therefore a series of lecture. Now, first of all, in LangGraph, there are two types of memory. One is short-term memory and another is long-term memory. Perfect. Now, so here there is something very important. Now, as I said, memory is a different concept. Memory is a different concept and persistence is a different concept. And without persistence, you cannot implement memory. But short-term and long-term memory are not dependent upon whether persistence is RAM-based persistence or a durable persistence. You can have a short-term memory with RAM persistence. You can have a short-term memory with durable persistence. You can have a long-term memory also with RAM persistence. Please note, long-term memory with RAM persistence. And you can also have long-term memory with durable persistence. Now, some of you might have felt long-term memory with RAM persistence. Does that make sense? Yes, it does. Because memory type is about what you store, not how you store it. What it means is you need to first understand memory as a concept. So, first of all, understand memory. Short term memory is a conversational memory, and long term memory is the memory about the user. It's the memory of the user. Short term memory is a conversational memory. Right now, I'm speaking to you. This lecture is a conversation between me and you. If you can remember what I said earlier in this conversation, that is short term memory. Or you can recall this conversation, this lecture, then that is a short term memory. Then what is long term memory? Long term memory is user memory. If during this conversation I learn something about you, your name, your preferences, your behavior, your likes, your dislike, and I also remember and extract that information about you, not in this lecture, but in all other conversation that we did. So maybe in one of the conversation we talked about your preferences in coding. Maybe Python is your preference over Java. Okay. In the next conversation, we talked about your educational background. In the next preference, in the next conversation, we talked about, okay, what you prefer in travel. In the next, we talked about your religious preferences, philosophy, psychology. And if I start collecting the data in the different conversation that I do with you and I make a user profile, that is a long-term memory. what my user want, and that enhance the user experience, and that you feel when you interact with ChatGPT. Okay, and that is your long-term memory. So remember this very, very clearly. Short-term memory related to conversation, long-term memory related to user. Now, the second thing, this concept is very critical. Now, the second thing, the subtle concept that I want you to feel, because memory is about feeling, and I want you to feel in this lecture is that LLMs are always stateless. And I want to focus on LLM are memoryless. Any large language model on this planet, whether it is OpenAI model, Llama, Gemini, any model from any organization, they are memoryless. They are memoryless. They are stateless. And specifically, they are memoryless. They do not remember anything about the conversation. They do not know who you are. They do not remember your past interaction. They only respond based on current input. That's it. Current input. They don't have the concept of memory. Now, you might say, but when I use ChatGPT, it remembers everything. Yes, but understand this very, very carefully. The application like ChatGPT has memory, but the LLM behind it does not have memory. A large language model is fundamentally just a mathematical function with parameters. So they only understand parameter. So they only understand the mathematical equation and the parameters in that mathematical equation. So when you give an input, it just generates the output. That's it. No memory about you, no memory about the conversation, no awareness about you, no awareness about the conversation, no awareness of your identity. And in this lecture, I'll make you feel that. Now, the third thing, even LangGraph by itself, LangGraph. Now, some of you who have studied LangGraph will say, what are you saying? Now, the third thing, which is important, even LangGraph. Now, some of you might get surprised that LangGraph in itself is memoryless until and unless you implement persistence, until and unless you explicitly add persistence component, the persistence component that you studied in the last lecture. You will feel LangGraph has no memory, and I'll prove it. Without persistence, today I'll prove it. LangGraph has no memory. So, how do we introduce memory in LangGraph? We need three critical components of persistence: state, thread ID, and checkpointer. State, thread ID, and checkpointer. Definitely, it is a RAM based persistence, and we can have a durable persistence. But these are the bare minimum. Without that, you cannot feel memory in LangGraph. State, thread ID, and persistence are the bare minimum component. Perfect. If even any one of them is missing, state is there, thread ID and checkpointers are not there, you will not feel memory in LangGraph. You may have logic, you may have flow, you may have nodes, you may have edges, whatever. You will not feel memory and you will not feel continuity. Okay. So if you only define state and if you haven't defined your thread ID and checkpointer, no past, no continuity, no memory. So what we have understood so far, LLM LLMs do not have memory. They do not have memory. LangGraph also does not have memory unless you build it using persistence component. And this understanding is critical before moving and understanding the implementation of short-term memory and long-term memory. Okay, now let's move this concept into reality. Till now, we have discussed the concept. We understand everything intuitively. Now we'll get directly into the code. And the first step is we will step outside the land graph, will directly interact with an LLM, and you will see it yourself. Every call is independent, no memory, no continuity, purely stateless and memoryless behavior. You will see this, you will observe this in a minute. Then what we'll do, we'll come into land graph, and even there, you will feel it. You will observe the same thing. No short-term memory, no long-term memory until and unless you introduce persistence. So this session is about to feel the land graph and LLM are memoryless until and unless you incorporate the concept of persistence. Okay, with that, let's move into the code. Okay, here comes the interesting part. We'll prove that LLMs are stateless. And first we'll do without land graph. Okay, So what we have done, we have implemented a LangChain library just to call an LLM. That's it. Call the LLM, and the LLM model is Llama. This is my API key, and I'm creating an object with the help of chatgroup class. This is the LLM object. I'll use LLM.invoke to connect to my LLM, the large language model, the Llama model. Okay, so let's run it. This is my LLM object. Now here I'm communicating with LLM. So I'm saying LLM.invoke. So I'm communicating with LLM. This is my first chat. Hi, my name is Saurabh. Perfect. Let's see what the response LLM has given. So for that, I'm doing output.content and it's saying, hello Saurabh, it's nice to meet you. Perfect. Now I'm asking again, LLM, hey, what is my name? I just provided my name, Saurabh. Hey, what's my name? Okay. So the interaction is complete and the output is there. Let's see the output. I don't have any information about your name. Does it feel weird? This is actually happening behind your ChatGPT, even with OpenAI model. This is exactly happening. So ChatGPT has implemented memory concept in the ChatGPT, but the model that it is interacting, it is memoryless. Hope you felt it. I just communicated my name, Saurabh, to the model, to the LLM, to the Llama model, but I haven't got any response related to my name when I asked, what is my name? Weird. Perfect. So we proved that LLMs are memoryless. Perfect. Now, what we have to prove and feel? We have to prove and feel that LangGraph is also memoryless and stateless if you do not incorporate the physical component of persistence, that is state, checkpointers, and thread ID. Let's see. So this is LangGraph basic library implementation. Okay, I'm defining the node, and node is very simple. The node is to communicate with the LLM. So it will simply communicate with the LLM. And see, I have used the basic capability of state. I'm not creating any state dictionary, but I'm using the capability of state, but I'm not using checkpointers and thread ID. Okay. Just to prove you that even if you implement state, one of the component of persistence, you cannot feel memory. Now, because you just have to start, then you have to communicate with the LLM, and there is an end. So very simple edges I'm creating. Oh, sorry, I haven't defined it. So very simple edges I'm creating. Now I'm building my graph. Sorry, I'm compiling my graph. So you see a very simple graph. Start with the conversation or the input, invoke the model, and take an output. End. That's it. I'm invoking my graph with a content. Again, I'm saying my name is Saurabh. Perfect. The response is, hello Saurabh, it's nice to meet you, blah, blah, blah. Now the second question, I'm asking to my LangGraph, hey, what is my name? I'm storing it in output. Let's see what output message has. What is my name? I don't have any information about your name as our conversation has just started. Weird, right? You're interacting with the LLM with the same information that you're asking that you just passed on. But LLM doesn't have a memory. They do not remember who is Saurabh, what is Saurabh, why is Saurabh. And therefore, you are getting a response which feels weirder, but that's logically how LLM has been built. Perfect. Okay. So in this session, what we try to do, we try to build a very important concept. The concept is LLMs are memoryless. Your land graph without persistence is memoryless. Now we have to study two different types of memory, short-term memory and long-term memory. And if you don't understand short-term memory and long-term memory, you cannot build any AI system, any chatbot with a great user experience, because this is the experience that you're going to provide if you just implement LLM. Okay. And that's why I generally say that just connecting to an LLM doesn't make your process smarter. You need a right framework and a right building block. Perfect. So the next session, what we'll understand in the next session, we'll try to see that how we can implement short-term memory with a very simple trick. And that trick will then try to implement in LangGraph through the persistence component. Perfect. So next session will start implementation of short-term memory. Okay, we'll understand, we'll feel it, and we'll implement the short-term memory. Our first short-term memory with RAM, because what we have to study, short-term memory with RAM persistence, short-term memory with durable persistence. Then we'll study long-term memory with RAM persistence, then long-term memory with durable persistence. That we're gonna study. With that, I'll pause here. Thank you. Have a nice day.